Here's solutions to perfect problem 2. The data below lists the total 2011 regular season wins for the 30. Nice that I told us that. That's what N is, Major League Baseball teams. And I even put them in order here, which is kind of helpful because we're asked to create a box plot. And to create a box plot, we need to know, well, we need to know a lot of things. We need to know what the minimum is. So in this case, the minimum is 56. We need to know what is Q1, what is the median, what is Q3, what is the maximum. Maximum was Phillies, I think. Yeah, Phillies won 102 games. The way you figure out the median is it's the n plus 1 divided by 2, or in order to make these all seem a little bit more similar, I'm going to say it's the 50 out of 100 times n plus 1, which is 30 plus 1, which is 31. The reason I wrote it like that is because now the rest of these look similar. The first quartile is the 25 divided by 100 times 30 plus 1, largest observation. And this guy, the third quartile, is the 75th percentile, 75 divided by 100 times 30 plus 1, largest observation. Largest observation. Largest observation. Okay, let's see. 31 times 25 divided by 4. This number right here is, maybe I change colors. This number is 7.75. This number in here is 15.5. And this number in here is 23.5. 23.25. Okay, so you can't take the 7.75 largest observation, but what you can do is average the 7th and the 8th. So that's what we'll do here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Might as well number the rest of them because I'm going to need this later. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, and 30. Okay, so to find the first quartile, what I have to do is take the 7.75 largest observation, which is the average of the 7th and the 8th largest observations. So it's 71 plus 72 divided by 2, which is 71.5. Same idea here. I take the average of the 15th and the 16th, the average of 80 and 80, which is just 80. And for the third quartile, the 75th percentile, I have to take the average of the 23rd and the 24th. So the average of 90 and 91, which is 90 and a half. Okay, so I've calculated a lot of things. I need a couple more. I need to know the interquartile range, which is Q3 minus Q1, which in this case is 90.5 minus 71.5, which is 19, if I calculated that right. And then I need to calculate the lower fence and the upper fence. And I have formulas for the lower fence and the upper fence. The lower fence is Q1 minus 1.5 IQR, and the upper fence is Q3 plus 1.5 IQR. So I have all this information. Q1 I figured out was 71.5, and from that I want to subtract 1.5 times my intraquartile range, which is 19. Kind of same idea here, except now it's 90.5 plus that. And I can calculate those. 1.5 times 19 is 28.5. So 71.5 minus 28.5 is 43. And 90.5 plus 28.5 is some huge number, 119. So in this case, my lower fence and my upper fence are below and above my min and my max. So these are kind of my thresholds to figure out if any of my observations are outliers. In this case, none of them are outliers, so it makes this a little bit easier. All I have to do is, well, maybe I'll start with the number line. Let's see, winds go from 50 to 100-ish. So let's see, 75, 60, 70, 80, 90, 100. So now I can create my box plot. My median is at 80, 50, 60, 70, 80. My Q1 is 71.5, so somewhere in there. Q3 is 90.5. So you get something kind of like this. My max is 102. And my min is 56. So get something like that. Hard to tell here. It looks like maybe my data is a little bit left skewed because this tail is a little bit longer. Although it's a little bit hard to tell. It's not too far from symmetric. But at any rate, no outliers. Here's your box plot. I guess if you wanted, you could label these as Q1, M, Q3, max and min. Something like that. But something similar to this. Yeah, maybe even throw in the values. Why not? Minimum was 56. Q1 was 71.5. The median was 80. Q3 was 90.5. And the maximum was 102. So, okay, something like this is my box plot. I think that's good enough to call this the end of this perfect problem.